Dear students, today we see about the transverse vibration of free beam with and without concentrated masses. Aim of the experiment to determine the natural frequency of a beam by deflection method. So, apparatus secured, experimental setup, dial gauge and meter scale and masses. So this is the experimental setup. This is the simply supported beam, and this is hanger 1 and hanger 2. This is dial gauge. So here we are going to add the mass in hanger. Dear students, now see about the pictorial representation of the experiment. So this is the pictorial representation. So this is simply supported beam, and this is on a hanger 1 and a hanger 2. Here is the dial gauge. This is the center of the simply supported beam, and then this total length is capital L, and the hanger 1 is distance from the fixed end small a, and another end is also a small a, and in between the distance of the hangers is b. So now going to see about the formula. Natural frequency omega n is equal to root of k by m. M is the mass of the system, and k is the stiffness of the bar. So k is equal to load by deflection. So now we are going to do the experiment. So first we are going to ensure the dial gauge in the null position, that means 0 value, and then to add the weight from the hanger 1 and also hanger 2. Now we are going to measure the deflection of the dial gauge. So for this mass from 0 to it will move on the 10. So this is the deflection of the beam for a given mass. Now we do add the masses for the again second trial. So we are going to add the mass in hanger 1 and hanger 2. Now we noted the deflection of the dial gauge. So for this 200 grams, and we additionally added to the 200 gram. So totally 400 gram. We got the dial gauge deflection, the 22 divisions. 22 divisions means, so 22 mm. Here the one division is equal to 1 mm, the noted in the dial gauge. So we got the 20 mm deflection of a applied mass. So we already taken the reading of the dial gauge. So first we are going to see the tabulation. So first one is length of the load. So the hanger is noted in the distance small a, that is the length of the load, and weight added in hanger 1, weight added to hanger 2. So here we first added the 100 grams, and added to the hanger 2 also 100 grams. So totally 200 grams. For this 200 gram we got the 10 mm deflection, and then we are going to calculate the stiffness. K is equal to load by deflection. So we already have the load value, and finally we find the stiffness of the bar, and then we find the natural frequency of the system, root of k by m. So for this calculation we find the natural frequency of the system. So and also we find the by using the deflection method. So result, thus the natural frequency are determined by the given free beam setup. Thank you.